All right, cool. Hey, first and foremost, thanks. Thanks, everyone, for being here. And thank you to Linux Foundation as well, allowing Amar and I to come here and share our experience on slicing. And no, Seth, it's not the slicing we're thinking about. It's not pizza either. We're going to talk about 5G slicing, and we're talking about network slicing. And what does this really mean? So other than this challenge of this screen going back and forth, we'll figure this out. All right, so our intent really is to share our experience of doing this for at least last 3 years on what this is. So we're trying to keep it to real networks and what we've done and how it helps and all that. Having said that, my name is Hitendra Sonny. I go with my middle name, Sonny, just to make me sound a little brighter, or Seattle Sonny, that could be help. I lead business development and marketing at Kaloom. Thanks. Thank you all for joining. All right, so we'll keep going. So again, as I said, as Amar sets this up, both Amar and I and our companies, Kaloom and Aarna Networks, we work together with various providers on tying it all together, because there is so many different misconceptions or thought process. They say, well, what is slice and how far slice does it really go? So our intent is to talk about end-to-end slicing. We'll define what that is. We'll show clippings of some of our real live demonstrations or real live POCs that we've done. And hopefully we'll leave some enough time towards the end to do some Q&A. Amar?
Yeah, so in terms of introductions, I'm Amar Kapadia. I'm a co-founder at a company called Aarna Networks. We are quite involved with a number of Linux Foundation networking and Linux Foundation Edge projects. In LFN, projects like ONAP, MCO, Open Daylight, and LF Edge. The main one we are involved in is Aarna. And we'll talk more about the Aarna one. And we have a open source orchestration product based on these projects.
Great, thanks. So I guess if you can help me go to the next slide. So let's just set up the why, right? As one of my mentors always said, if you figure out the why, how gets easier to do. If the motivations are so look, we'll talk through technology and all this stuff, but ultimately, when you look at the 5G, there's huge amount of investment that's going into 5G and Edge. I mean, we'd all have to be in caves to know that that's not the case, right? So Edge, 5G, significant amount of investment going on. And why? How are we going to get the ROI? So what we try to get the slicing towards is view slicing from monetization perspective. I, as a service provider to enterprise customer, or I, as an enterprise customer, serving multiple constituents in my company, I have to find a way to deliver services to my end customers. And in doing so, I also have to do differentiated services. Different services require different parameters from network, different latencies, different throughput, you name it, right? So the whole idea with slicing is really look at it from monetization perspective. All of us have been through networking in the world. 5G defines slicing from up to transport level perspective. Some of us have been through this. I come from having done networking all my life, and we talked about VLAN before, and then VLAN was one way of doing microsegmentation of keeping traffic away from each other and delivering each VLAN the parameters that it needs. Same thing we went through with VXLAN, same with slicing. Now, slicing has been defined in the 3GPP community from the 5G perspective, but our intent here is to take it beyond that and talk all the way, because ultimately the application resides somewhere in the cloud or somewhere in your enterprise. And your 5G RAN to core to all the networks may reside completely somewhere else. So how are we going to take the slicing all the way and deliver the monetizable service? So what is monetization? So we all know what monetization is, but why do we need it? Look at the workloads that we are delivering on the network. And look at the ARPUs of the network, average revenue per user. On mobile cell phone, probably use a lot less bandwidth, yet you're generating a lot of A lot of revenue from that perspective. Now replace that with some other applications, whatever that may be. That may even be autonomous cars. We're not gonna end up paying $50 a month for an autonomous car for it to do certain things. So your revenue is gonna, from you drive from that perspective, is gonna be much lower. Maybe $2 a month, maybe $3 a month, kind of stuff. So different applications are gonna require different things. Some of the things we'll talk through are what are the applications, and yes, we hear a lot of things about Industry 4.0. We're demonstrating what the Industry 4.0 use case, which I'll talk through a little bit later on what exactly we're doing. But the idea here is different applications need different network and overall resource parameters, and how do you slice them out, regardless of where they are? How do you slice them out and then deliver that quality of services or deliver on that SLA? That's really where slicing is really all about. Some of the things as we go through, and this is a portion of the webinar that we had done. The networking that is going to need all the way from UE all the way to the cloud, if you will, that networking fabric is going to have to deliver this capability where you could take all these different disparate networks, all the different resources from compute to storage to servers to applications, and really create one as a contiguous resource across the network. So the fabric is going to have to deliver kind of stuff. So that's what we're talking about. We also are talking about, a lot of people ask even earlier where we're doing this, is this a service provider thing? Is this enterprise thing? Answer is yes. It is both. Both ways we're going to need it. So it is not just dedicated to public networks. It is both between public and private networks as well. So if we can go to the next one. So what is, first let's define where that is. And this is where we see a lot of, so what is edge, right? We talked about a lot of investments going over here. We talked about a lot of investments going here. What is edge? And again, this is how you define it. If you're a service provider, perhaps you remain at the aggregation edge, right? And you as a service provider may be dealing with other providers around in the network. May that be interconnect services providers, may that be core services provider. So what you define the edge up to service provider level here, but you as a service provider are also going to bring your services to your enterprise customers. So from our perspective, edge definition, depending on your end user enterprise or your service provider, all the different areas have to be able to factor it in. And one of the key thing is, so where did the word slicing must go on come? And I know I'm jumping to my 2 slides from beyond, but we were doing work with Equinix. And both Amar and I have been involved with Equinix for good, I would say, 2.5 years now. And we got to give credit to Equinix and specifically Oleg, where it comes with slicing must go on. And that's exactly what the whole idea is. If you do some amount of work in enterprise, you do some amount of work in the edge aggregation, but that edge aggregation now has to go beyond. Your customer's traffic must traverse perhaps worldwide. If Honda is doing something in Japan, and their slice must come all the way to the United States, for they have facilities over here, they're not going to have the network across the board everywhere. So they're going to have to rely on somebody in the middle as an interconnect services at Equinix. So that's where the terminology slicing must go on was born. And our take is when you look at slicing, please look at it from all the way perspective. Do not just look at it from transport perspective, but end to end, all the way to the cloud service providers and where the application resides, regardless. Omar?
Yeah, I think the main point of this slide is whether you're doing private 5G or public 5G, your slice is going to straddle multiple locations, multiple vendors, multiple domains. That's sort of the point of this slide. So if you are in a private setting, it's pretty easy to imagine you might keep maybe your RAN in the edge data center, your core maybe in the regional data center, and some other functionality in the central data center or a public cloud. And like Sonny mentioned, you can't just think of slicing in the traditional RAN transport core, right? That's the traditional definition of slicing. You can't just think of it in that sense. And you have to think about, what are the connections between these data centers, and public cloud connectivity. All of that has to support the SLA for the slice to be valid. And that's what we are going to show through concrete examples. And what that means is now you have multi-vendor. So even if you say I'm a public 5G and MNO, and I'm going to purchase my 5G completely from one vendor, why do I have to worry about multi-vendor? Well, you still do, because as an MNO, if you are offering slices to enterprises, they might be doing different things. They might be taking it to a different data center, or like Sonny said, across the world, and using different UPF, or they might be using different edge computing application vendors, different fabric providers. So multi-vendor is reality. Cross-domain, we talked about cross-domain. It's not just RAN, transport, and core itself is cross-domain, but now you have to say inter-cloud connectivity, WAN connectivity. All those things also come into the cross-domain. So as the slide says, RAN, edge transport, and core to cloud with domain and cross-domain. So now orchestration is a big piece of setting up the slice, and we'll touch upon that a little bit. And the orchestration now has to worry about doing it within a domain, and then cross-domain to set up the entire slice. So with that lead-in, you see that slicing has many challenges that have to be addressed. For example, slices must run in isolation, and each slice is used to solve a specific business problem. So again, let's take the private 5G context and the public 5G. So in a private 5G context, you might have one slice for drone control in your factory. And you might have another slice that's for uploading your video surveillance video to a machine learning application. These slices have very different attributes, and you want them completely isolated. You don't want the drone control to be treated like the high bandwidth one or vice versa. And in public 5G, if you are offering enterprise slices, clearly, they all have to be completely isolated and secure. And if you attended the Ops 5G talk this morning, the Ops 5G project is dealing with secure slicing. That's one of their main areas of focus. So support a model-driven multi-layer architecture with open APIs. In this world of heterogeneity, you have to have open APIs. And multi-layer, I will talk through the architecture of the orchestration. You will see the different layers. And model-driven, again, if any of you attended the Nefio talk this morning, there was discussion about how you should be able to express your intent in very simple, high-level mechanisms, and everything below that, happens automatically. Cost control, Sonny talked about the ARPU problem. Cost, of course, remains a big concern. And the next two bullets sort of support the top three bullet. So I'll go through them a little bit quickly. So slicing requires the ability to configure the network functions, because for each slice you have to configure them. And you need flexibility, programmability, and control to configure these, modify these network resources on demand. And the last two deal with dynamic slicing. So slicing can be done statically, or it can be done dynamically. So you could say, I'm going to set up these 4 slices, and I'll revisit that decision 3 years from now. And that's all I'm interested in doing. Or you could be talking about it dynamic, in a dynamic sense. Slices are coming up, they're going down, they're getting reconfigured, they're getting optimized based on the usage. And the last two talk more about the dynamic aspect of slices, where you want to put slice management in a CI/CD or a DevOps flow. So whatever change you express on the intent automatically flows through and changes the slice dynamics. And for that to happen, you obviously have to monitor. And based on the resource usage, you look at conflicts, you look at optimization, et cetera. So with that, we'll go into something more concrete. And Sonny, maybe why don't you start off this slide?
Cool. So I'll go off the slide a little bit, and I'll use my favorite line that I say that a lot. It takes a village. And it does indeed take a village. I really don't think, no disrespect to any vendor, including myself as a vendor, Kaloom, no one company can deliver it all. These are new technologies. These are new requirements. If 5G were not new enough, then we've got the edge, which is new now, and we may be doing Kubernetes applications, which is new now. So when I say no one company delivers it all, meaning someone's going to have to put it all together. And it is going to come from multi-vendor is really the point that I'm stressing. I think the day where you just have one vendor doing all of it, including services, I don't think that's a reality anymore. And when I show this slide and we'll show the next slide, it speaks to that a little bit. But the second point I want to stress with that is if multi-vendor is a reality, open source equally is a reality. And a couple of examples, even before I go into the share, and Amar, I hope you'll be okay with the things. But so he talked about management and orchestration is the thing. So we are an underlay physical infrastructure provider. Somebody else is going to provide the overlay management and orchestration. I don't think we're going to create a complete abstraction layer where you don't need anything from physical layer. I don't think that's going to happen. It's just what we're going to use. So give an example. When we did this work with Equinix, initially we started out on the far end with UE and G Node B. It was emulators because the market was not ready. Right? So it was all emulators, and I'll come to the next couple of slides that talks about how we advanced just within the last 18 months. But the another part of the advancement we saw, so us as a physical network provider, infrastructure provider, have to give open interfaces to a management and orchestration, right? So initially we started out, and my intent here is to talk about maturity. When initially started out, there was one vendor was chosen, and at that time it took us about good 8 to 9 weeks for even the packets to start moving in orchestration to C. When we got together with Amar, because Equinix wanted to bring the completely open source base, we managed to get it done in less than 5 weeks. Fourth week, right? So, and then we've done with a couple other vendors as well. So I want to show the maturity of that is happening. And it is going to be required. So open APIs, open source, multi-vendor are absolutely a given thing. So what did we do here? What we were trying to show is, in this case, we were going to take, though we did emulation over on the UE and G Node B side, intent is to initiate a session, a slice, and these two different colors are intended to show the different slice. Initiate the slice that has connectivity all the way to the cloud. And all the way you go from UE to AWS, and what was required in doing that. What does network have to deliver, which we provided? What does the UPF have to deliver? So each and every, if you call it a parameter or requirement of that parameter, was all fully identified. And once that integration got done, and then the management orchestration took over, and how many clicks did it take us to do that?
Given the standardization that has been done by 3GPP on slicing, and the fact that vendors are increasingly supporting those standards, it didn't take that much time. So in fact, on the orchestration side as well, it was a journey. We first started by supporting core slicing. So, and I'll show in a subsequent slide how we supported that, but we supported a complex 5G core that had a Kaloom UPF along with other network functions from Capgemini engineering. Then in a subsequent effort, we did orchestration of the right-hand side, where we did orchestration all the way from Equinix, using Equinix Fabric across data centers and to the public cloud, and we'll show you that as well. And the next thing that we are going to do in an effort that Sonny will bring up later called the 5G Super Blueprint is RAN slicing. So at that point, we will have all the way, we'll have a full slice that goes on.
Absolutely. So again, a little bit on Equinix, and then the next one got even more real. So this work was done in the lab, though it's spaced across not only United States, but internationally. And then the next one we did, if we can go to that one. So this network, if you really look at this one, let me start with a little bit of bragging, not for us who did it, bragging for the customer who implemented this. This was done at Telenor. And this was the first network of its type. This network, let me work backwards. Glomo 21 Network Innovation Award. This network won the Innovation Award. Nice color scheme, but look at it. 8 different vendors. 8 different vendors. All of them working in the OpenShift environment. In this case, Red Hat OpenShift is what Telenor, for that specific project, had taken. All of us are completely containerized. All of us are totally connected together, delivering different functions. And as I said, with Equinix, we were doing emulator. Here, we were not doing emulators. This was real network. This was real network that passed the traffic among all of these 8 different vendors, providing different functionalities. We've seen this to be a reality, but this was deployed as a reality. Telenor not only did this from the lab perspective, but we went beyond, and we had 2 customers of there, a radio station and a defense requirement. So we ended up creating 2 different slices spanning across all these different vendors, all the way from Huawei doing the radio to the final network. And we delivered those. At that time, I will also say, it took us good 8 months. There's a reason I'm saying that. It took us good 8 months for all of us vendors to come together. And yes, we were all supporting OCP, fine. But even then, we had to do a lot of work with ourselves together. And that work now applied to the second and third customers we've done since then. It gets easier. It absolutely gets easier, because my intent here is to say that when I come towards the end to Super Blueprint, and Amar will add more to that, is that we've been through all these hard knocks, if you will. And the open source multi-vendor networks are indeed ready. There's no doubt about that. We're out of demos. We're kind of out of POCs. We're going into pilot, and these are production ready. That's one of the key things I wanted to stress. So if you may, just quickly to show you the whole thing here, one more click, it will go quickly. But the idea here is between a radio station and a defense, they both had a completely different requirement. Completely. What one wanted, and they wanted to make sure that we deliver a certain amount of bandwidth regardless of what other slices gets rolled out. So when the next slice got rolled out, as you can see, that slice went from 10 meg all the way up to 306 meg. But the intent here was to make sure that nothing on the left-hand side, the radio station that was delivering the radio, could not be impacted. So this was all done. This was delivered. There's many more things that go in there. And that's the reason Telenor won, amongst all the partners together, the Network of the Year award. And again, intent is the credibility of the technology that has advanced, that is there. That's the key message we want to pass on.
So I'm going to touch upon another blueprint. This is from Linux Foundation Edge in a project called Akraino. And this particular blueprint is called Public Cloud Edge Interface, or PCEI. So we submitted the work done in the PCEI blueprint for ETSI and LF-Edge Mech Hackathon. This was jointly between Equinix, us, and other PCEI members, and we won the first prize. And this effort focuses on the sort of the right-hand side, not the RAN transport and core, the RAN backhaul and core, but sort of the data center to data center to public cloud connectivity, and how do you maintain slice SLAs. So what this shows is this 5G network was in Silicon Valley, Equinix Silicon Valley. The UPF and the Azure IoT Edge application was in the Dallas data center. And then Azure IoT Hub was in the public cloud in Azure. And the connectivity had to ensure that the SLAs were met. And so we showed all of this working along with the orchestration. And essentially, this demonstrates the slice must go on concept. And just to make a point on orchestration. Orchestration is a very important point of slicing. And you have to be able to set up the slice, manage it, optimize it, and ultimately tear it down. And 3GPP has defined a modular architecture, which makes it very easy for heterogeneity. And all of what you heard through Sonny in terms of multi-vendor and multi-domain is enabled by this architecture. So at the top, you have the Communication Service Management Function, or the CSMF. That's where the user expresses their slice intent. It can be through GUI, it can be through different means. That goes to something called the Networks Service Management Function, Network Slice Management Function. And that's the one that decomposes that across these different domains. And traditionally, if you look at projects like ONAP, there's a lot of work gone on into the RAN, transport, and core. And each one has something called the Networks Slice Subnet Management Function, which deals with that specific domain in terms of configuring the slice. And then we took the core NSSMF, and that's the one I mentioned. In 5 weeks, we were able to adapt it to a combo core from Kaloom and Capgemini Engineering. And then I've put 2 more in sort of different color to provoke a discussion or to ask a question, saying, should we think beyond these 3 traditional NSSMFs to, say, cloud fabric and cloud connectivity as well to realize the full end-to-end slice vision?
So being mindful of the time, I know we've got 5 minutes or less. Just very quickly, the journey of the blueprint. There's a lot of talk about going blueprint. I hope all of you will be able to attend a keynote tomorrow. I don't want to give out too much and steal the thunder, but in a keynote tomorrow between Linux Foundation and IBM, there's going to be some demonstration done. And then we at Kaloom's booth are also demonstrating some of the things. But the journey of the Super 5G, it was known as a VCO 3.0, Virtual Central Office 3.0. And the Virtual Central Office gave name to a Super 5G blueprint. And the intent was exactly what I've said maybe at least 7 times. That is, open source based, multi-vendor, end-to-end network delivering applications. And tomorrow we'll be showing applications that are edge-specific applications and how you could actually trust the multi-vendor network into doing that. So Kaloom has been participating with all this. I remember exactly almost to the 3 years now. That's how long I've been with the company. I was exactly at this event right here. 13,500 people watch 5G calls being made between China and through Montreal office to the San Diego where we were. That was my first day of working. Market has come a very long way in those 3 years, and we're very, very happy and proud to say that we're ready. Maybe one quick one, and I guess one quick one, call it shameless plug or something. I work for Kaloom, so I got to take a little bit about Kaloom. This is exactly what Kaloom is delivering. With Red Hat, we call it a collaboratively envisioned and developed product called Unified Edge. And the intent of the Unified Edge is regardless of where this is residing, may that be at a customer prem, or may that be at the edge aggregation of service provider. The idea of that infrastructure is to be able to deliver you the capabilities of delivering the slices and user experience that you need to deliver for those applications as a service provider or an enterprise. A couple of very, very quick things. So why we do Edge, if you think about it? If you go to Virtual Central Offices, there's hardly any room there. There's no room, I mean, they're loaded with frame relay switches and ATM switches, and some of you don't even know what that is, right? But it's all loaded with that. There's hardly any room. We're power, space, and cooling constrained environment. Whether that's service provider like that, or you go to Home Depot, and then we did that at my previous company, we did all the Home Depots. There's not that much space available. Our thing here is the joint work we did between Red Hat and Kaloom is to be able to deliver most applications with the smallest footprint. And that's the key message. Most applications delivered through the smallest footprint and with the scalability required. And obviously, outside of scalability, you require the slicing. So slicing must go on. And that's where we'll stop. Amar, do you want to?
Yeah, just, I mean, in spirit of that, where we come in is we'll orchestrate all of this using Linux Foundation networking projects, essentially.
Say that, we'll stop here. Thank you all for giving us 40 minutes of your time.
Thank you. I think we have a minute or so if there are any questions.
A quick one. Where do you see, as you shrink the architecture down, and I really like what you guys are doing with the switch and everything. Are you seeing like low power ARM RISC processor architectures kind of coming out to the edge, and how do you intend to keep up with that?
A very, very good question. So how will we keep up with some of the developments that are going on in the industry? So one of the things we did differently, and I didn't want to go into the thing, one of the things we did differently is we're leveraging a programmable language, P4. The whole idea of the programmability is before you commit to the sand, as we call it, ASIC, application specific. So instead of doing that, if we were to do a programmable language where we could change the hardware target as we need to go. Ian and I were talking a little bit earlier, we were so far doing it in the switches, then we're doing it in smart NICs, DPUs that are becoming really available now and all that. So the idea is to take that and deliver your software, so we're a software company, deliver your software such so it has that transportability to what it need to go. As far as where we go to the customer, like we're involved in this one customer in Japan, massive requirement, a lot of terabits to be done, but the space is so small, and power budget is so small. How are you going to deliver multi-terabit of performance with 4 million subscribers with the power budget you have? So you're going to need all of these things together. Hope that makes sense. Any other question? Thanks again, all, and I'd love for you all to come by
Thank
Kaloom
you.
booth and show you that.